This is the principle of a capacitor you may have struggled with. If your teacher had explained it this way, you'd be financially free. The structure of a capacitor is very simple. Inside are two conductive plates separated by an insulator. When connected to a power source, electrons flow from the negative terminal. The insulator blocks the path, so negatively charged electrons build up on one plate. The electric field repels electrons from the other plate, leaving it with a positive charge. This creates a potential difference, or voltage. Now we'll disconnect the power and connect a load, like an LED. Due to the potential difference, electrons flow from the negative plate to the positive. As a result, the LED lights up. This is one of a capacitor's basic functions, storing energy. You might think it's just like a battery, but their functions are quite different. This practical application will show you. In this parallel circuit, when the power is on, current flows to both the capacitor and the LED, charging the capacitor. When the battery suddenly stops providing power, the capacitor's stored energy discharges, briefly maintaining the circuit's power. When the power source returns, the capacitor begins to charge again, waiting for the next chance to discharge. We can compare a capacitor to a water tower. A water source fills the tank. If the water pressure becomes unstable or stops, the stored water in the tank can temporarily maintain the outflow until the water is supplied again or the tank drives running. Maintaining a stable voltage is one of the capacitor's main functions. Furthermore, a capacitor's discharge speed is much faster than a battery's. In this setup, a battery directly powers a motor, and its rotation speed is slow. Now, if we add a capacitor, first we use the battery to charge it, then we switch the circuit to let the capacitor power the motor directly. You can clearly see the motor speed has increased a lot. This is because the capacitor provides a much larger instantaneous current than the battery, giving the motor a greater power output. Therefore, capacitors can power devices that need fast charging, like the flash in a camera. Besides that, capacitors also have the function to pass AC and block DC. In a DC circuit, the insulator's barrier means that once the capacitor is charged, no more current will flow. But when the power is switched to AC, the current's direction constantly changes. Therefore, the circuit can still conduct current. In daily electronic equipment, there are many PCB traces, wires, and leads. They all have some parasitic resistance and inductance. While the individual values are small, together they can affect the current stability, producing strong electrical noise. This noise is a high-frequency AC signal, and a capacitor can effectively divert this noise away. This function is called decoupling. It's very effective at removing electrical noise in audio. Have you learned it now?